I think we're moving a little bit more to the western part of Germany, to the city of Dortmund, where the Fraunhofer Institute for Software and Systems Engineering is located. Unfortunately, there is no video because it was simply not possible, but Anja Burmann, Deputy Head of Department Healthcare, will speak about the Institute's work. So the floor is yours. The floor is yours, sorry.
Yes. Thank you very much for the opportunity. I hope you can all hear me well. I will shortly share my screen. Yes, as Frau Ms. Wienand just introduced, we also wanted to invite you to a virtual tour through our institute, but unfortunately that was not practicable due to two reasons that I also want to share with you. The reason one is actually hidden between the two pictures that you see right now. Currently, our institute is situated in one floor of the building on the left side. However, we are also currently in a moving process to the building on the right-hand side, which is why there is not much to actually show in both of these buildings at the very moment. And the second reason is we as a software institute realize more and more that digital value creation actually not necessarily requires actual laboratories or offices. Since we are working for remotely for 1.5 years now, we are fine with that. And the new office does is not actually dedicated to offering specific desks for individuals, but rather a space for joint creativity and ideation. That space, however, is not ready yet, which I pity for the occasion today. Nonetheless, I'm happy to use this opportunity to introduce you to the Fraunhofer Institute for Software and Systems Engineering and our research activities. A few words on myself. I personally have an engineering background in biomedical technology, but most of my colleagues have an educational background in the field of informatics, data science, and software development. Fraunhofer ISST is part of the Fraunhofer Gesellschaft, and the ISST is a software institute situated in Dortmund. The leading motto of the ISST is innovations from data. What does that actually mean? We are dedicated to the digital transformation of economy and society and to the transfer of knowledge from research to practice, which is the DNA of Fraunhofer actually to work on this interface. This ambition also leads to higher goals, I would say, like creating whole data ecosystems in order to incubate the creation of value on the basis of data across organizations and along the, so to say, customer journey or human journey, actually. Therefore, we also work on developing technology to create safe environments for creating value on the basis of data across organizations. I will get back to this in the later course of the presentation. So what does that now concretely mean? What are we working on? We have 3 departments which transfer the idea of value creation on data into 3 application domains: data economy, logistics, and healthcare, which is my department. And our portfolio, the healthcare department portfolio, actually suits very well to the motto of the InnoHealth campaign: digital diagnostics and smart sensors. And a quick overview on the topic clusters that we work on. The first one is data-driven business models, so design and calculations to monetize data and base value on data. And that also goes hand in hand with questions of data allocation and access, which refers to actual tools like data marketplaces, but also processes and methodologies like data use and access control mechanisms and things like that. And the increasing availability of data, of course, also leads to the question of how to derive information from data, which leads to methodologies of data analysis and artificial intelligence. And with regard to that, we are developing applications and visualization tools for identifying or deriving information from data by using AI models and methodologies. Software development in this setting refers to the implementation, of course, the implementation of applications, but that is just a tool for implementing and also evaluating effectiveness and interaction of these theories with the environment. And yeah, I want to use the opportunity today to dive deeper into the field of data analysis, actually. This is until now mainly focused on very specific treatment paths. And it is also usually based on sensor acquired data, at least within our department, or data that is stored within electronic case records, for example. Fields of application that we are working on are epilepsy, Parkinson, stenosis, and others. And yeah, I will quickly go over this one because that also refers to a tandem, which is included in the campaign. And I'm sure you have met the tandem participants. But yeah, I just want to refer to the projects Epitect and BodyTune, which are also associated with our institute and collaborate with our researchers. I'm sure you are aware of this and had a look into these projects already, so I want to focus on two others, which also can be assigned to this area of sensor-based data use. The first one is Parkinson Companion, which addresses the challenge of processual and multimodal healthcare provision for Parkinson patients. It is actually obvious that changes in the regulation of the vegetative bodily functions, that means the sleep frequency that occurs, the sleep frequency that people actually show differs from people who develop a Parkinson disease from a natural disease pattern, from a natural sleep pattern. You can actually early detect Parkinson development when you are observing sleep of individuals. And this project aims at closing this gap with a screening and monitoring system for individuals who are more likely to develop actually Parkinson disease. Benefits are obvious and include early diagnosis, but also diagnostic accuracy, improved treatment quality, and most of all, better quality of life for Parkinson patients. Within this project, we are developing a sensor system for the acquisition of sleep data in a home care environment. And on top of that, algorithms which are developed for the purpose of representing digital biomarkers, which enable an automated data evaluation and which are aiming at intelligent derivation of disease indicators from these data streams. And the system is also supported by a telemedical video monitoring system, which is provided by one of the project partners. Within this project, we are applying methods from the field of machine learning, which are used to provide support for the early diagnosis and the prediction of the course of the illness. The data about the sleep and the neurovegetative state of the patient is collected using a specific somnography system. And the data streams are then processed and analyzed in order to identify patients at risk and construct a prediction model that can be used as a support for doctors or evaluating patients. Thereby, the project aims at providing a mobile screening system for the home care environment for the identification and management of Parkinson disease. The focus especially is on the early detection of sleep disturbances and underlying changes of body functions, such as slower movements or instability, in a general speaking. A second field of action is the project Mightyu. This one aims at the healthcare provision for patients with infantile cerebral palsy, which is a movement disorder, and that is caused usually by oxygen insufficiency, for example, during birth. And it is thus a chronic disease of the motoric system, and it leads to impairments caused by damage to the central nervous system, and in most cases it occurs in early childhood. And this project aims to develop an adaptable and motivating technology to provide training support for children with ICP. And we use muscle potential and kinematic data of the patient group and record these with an Emg Sensor system. And this data is then used and analyzed, transferred to a digital application and in a virtual environment for training and motivating patients to stick to their training routine. The application is developed to allow the group to also include their social environment and to collaboratively solve tasks within the application, which is aimed at improve emotional skills and social interactions for the affected individuals, and thereby strengthen cooperation with family members or peers and let them experience their own competence. Thereby, we want to create a virtual training environment which picks up the individual patient exactly where he or she is situated, and motivate them to follow their individual training routine at home. I want to show you a rough overview on the architecture and what that means with regard to technology that we use. The training data, which is recorded during each use, is shared through a digital platform, which is providing professionals like nursing staff or doctors insights into the progress of their patients, and which allows them to adopt or to adapt the training and therapy plan of the patient. The target group that we're aiming at is, as I mentioned, rather young. So we are trying to create a motivational environment which targets this group's interests. So we have different components which are working together. On the one hand, an adaptable user interface, and the application can be used on a console, on a desktop PC, but also in a virtual a VR environment. The prototype setting can be seen here. So we stick together all necessary hardware to set up a test system, which was then tested in a defined environment and also is currently in a testing process with actual patients. And on this picture, here you see the Emg sensor, which is actually sticked onto my arm. And this is used as the steering component for what is happening within the application. It can be attached to every muscle that you can imagine that needs training, and the setting is by this mean adaptable to the individual needs of the specific patients. So for patients with a poor mobility, the representation of the individual movements within the application, and especially within the virtual environment, is is exaggerated in order to optimize the perceived self-efficacy of the patients. So these two project examples that I just referred to show in a very specific context, in the context of Parkinson and in the context of ICP, that our way of living and also the way of providing healthcare is specifically increasing based on digital data. And the increased usage of data also leads to the question of whether all the data that is created around an individual along his or her life, would it actually possible to describe the individual citizen with regard to their data, the digital me, so to speak. And that is what we call the digital life journey, which is also a research project in a rather early phase. And that actually shows how people can regain sovereignty over their data and across organizations. And it also incorporates the factors society, technology, ethic, law, and economy in order to describe this on a framework basis, and also to develop technology to actually give back sovereignty to the individual with regard to their data. So as you saw today in this talk, and as also can be seen within the research tandems which are involved in the campaign, everything around us provides sensors and captures data which actually describe us. And the decisions regarding the use of these data are made only in the respective context, and in order to reach a human-centered service and ecosystem across service providers and boundaries is necessary. And this is the theoretical consideration which leads to the description of the actual data personal twin of a real individual. And this is in some cases no longer only a representation of data, but also incorporates autonomous behavior to enable interaction with ecosystems. And within this research framework, the digital life journey, we develop technical solutions which actually aim at supporting the vision of a human-centered way of using data across lifetime. This also leads to cooperation-centered thinking, of course, which is represented in the GaiaX driving, which is currently all over the place. And the GaiaX Association aims at exactly that, creating a data ecosystem within which within a domain, but also within whole economies, value can be created on federated data in alignment with use and access agreements, and on the basis of federated connecting technologies. And the GaiaX ecosystem, which we are also contributing to, is based on a three-layered architecture. We have the technological basis, the integration space in the middle, which results from actual application of the technology that is developed in the bottom layer. And on top, we have the actual value that refers to smart services, which are based on the data provided through the second layer. And yeah, this can be displayed like arbitrarily complicated, dependent on the level of detail that that any audience can handle. And that is certainly a big vision, which is currently supported and driven especially by the European Union, who calls European corporations to create a real data economy. We support this approach in dedicated research projects where we develop or focus on specific components which are allocated in the bottom, in the very bottom technology layer. and which focus on very specific components to create this whole ecosystem. I invite you to be part of this and collaborate, and I thank you for your attention and the opportunity to present this topic today. If there are questions, I'm happy to answer them, or I'll try my best.
Thank you so much. Especially the last point about data privacy. We heard yesterday from the Health Innovation Hub that due to data usage control, the Germans still love paper. And that has been a problem for a lot of years. And I hope that next year it will get better, because there are some policies that will be changed. So this is a very interesting point when it comes to personal to what you already mentioned. I don't want to repeat everything. So are there questions from the audience? You want to stick to the time, that's why you're not asking. So I just wanted to say that it was already mentioned that, but the ISST is part of a Tandem. And I want to share with you, for those who haven't seen all the tandems, just a link to all the participants of the InnoHealth campaign. And there you can find as well the ISST, which was represented by Maurice Beuting, who is also here today. Maybe you will meet him later at the booth. So thank you so much for your presentation.